bird. Right. So we had this construct, which is, let me write it here, def underscore underscore init underscore underscore. And what is the first parameter of the constructor?
Self, sir.
Self. What does self mean?
Object
Right.
first.
So you can add parameter 1, 2, 3, and so on. I can just say self dot name is equal to parameter 1, self dot id is equal to parameter 2. Right. So we can do this. Right. So what does this do? This is the constructor that gets called whenever an object is created. This statement straight away calls this function. Yes.
Yes, sir.
Right. Yes, now new method. New method is again one of the special method where new is the one which creates the object. After creating an object, init gets called. This is a constructor which gets called after an object is created. It calls after an object is created right at this point. Okay, when you are trying to create an object and the object is ready and it is getting called. So once the object is ready, that is why the first parameter is called self. The object is readily available for this function, right? Even before init, there is someone who creates the object and calls this init method. There is another function which creates an object and calls constructor, and that is our new. That is new. So new for the by default, right? It will not have self as a parameter because self itself is an object. So this is the one which creates an object, and hence it will not have the object created. So it is like a class method. It is like a class method. The first parameter would be the class, and then followed by star args. We'll discuss what are these two things, star KW args. Okay. I can write statements, whatever within that, but eventually they should always have return something like super, right? Class name would be class dot underscore underscore name, I guess. Then comma cls dot underscore underscore new underscore underscore cls, whatever the parameters that are taken here, right? The same parameter should go here within this. Okay. Or if you don't have any parameters, you can just ignore that also, right? So this, whenever you create an object, right? Now what happens? First, new will be called. First, new will be called. This is where it creates an object. This is where it creates an object. This happens internally, right? This is handled internally. We don't have to do anything about it. So this happens internally. And once this object is created, then your init calls. So always when creating an object, first is your new, which gets called. Second is your init method, which gets called. Okay. It is not like the moment I create an object, it will not directly call init. So first it goes to new and then it comes to init. But mostly we would be using init to create any of the object and assign values to the object because init will have the object reference, but new will not have. So new is the one which creates an object. New is the one which creates an object. Function that creates an object. That creates an object and then calls underscore underscore init constructor. Underscore underscore init constructor. Okay, now let us see programmatically what happens on that case, right? Hold on a second. Let me just create one class. Okay, let me just say class bird def underscore underscore new. Okay, now see the default parameters for the new are CLS, arcs, star arcs, and star star KW arcs. Right, so these are basically whatever the parameters that we pass. We will discuss about star and star star KW arcs, but ultimately what you have to, for now I'll just remove these things. Okay, for now I'll just remove these things. I'll just keep CLS and print is called. Okay, and then print, I'll just say something like this. Okay, and after this I'll try to create constructor def underscore underscore init. Right, there is no parameters for it. Print is called. Right, I'll just try to create an object. Now what happens? Right, which is called first init. Right, but after that, did your init got called?
No, sir.
Why? Because always new should see only if there is an object created, then your init will be called. Here, object itself has not been created. Here, object itself has not been created. Now, what is the second thing that I told? You have to return that object. You have to return the object. So how do we return the object? Right. So here, return. This is important. Otherwise, you will not be able to create an object. Return super. We will discuss what is super. Right. Super of class. So I will just say CLS dot name, comma, CLS dot underscore underscore new CLS. Right. So now if I run this, okay, super must be an argument, not string. Class name would be string. So I will just use as a bird only. Right. Right now, see what is the flow now? Right, it says now you are able to create an object. Now we are able to create an object because this is the step which creates an object. This is the step which creates an object. Okay. Now first, always whenever you create an object, first new method would be called. Underscore underscore new underscore underscore. That is the one which gets called first. And then once the object is created and returned, this here we are just returning a object that we just create. We want to create for this class. And once the object is returned, then is your constructor that is called. Then is your constructor called. Right. Let us see if what I'll do. I'm going to store this object. I'm going to print that object and I'm going to lastly return that object. We just want to compare when the constructor is called, they have self, right? Now self is nothing but object. I just want to ensure is that object same as this X? Is that object same as this? right? That basically proves whether whatever the statement I told correct or not, right? Basically, right? So new is the one which should create the object. So whenever you create an object, right? So underscore underscore new will be called first. Mostly 99% you will not use new, because when you want to create an object that is taken care by default, all you end up using is the constructor, which is underscore underscore init. But new, very rare cases you will use. I'll explain when we will use the new, but mostly you will not use it. But if you are using underscore underscore new, then you should ensure that you call this function. You should ensure that you call this super bird class this, otherwise your object won't be created. So this must be followed. This must be followed. Okay, and I'm just creating that object. This basically creates an object, new object, and I'm storing that object into X, and I'm returning that object. And whatever is the object that is returned from here, the same object is passed to init as a self. The same object is passed to init as self. Now let us see, let us compare. Now, are these both same?
Yes, sir.
Right? So they are same, but they are one and the same. For example, if you want to know the memory address, so this is basically technically the memory address of the object. So there is another function which gives an integer representation of the memory address, which is called ID, which is called ID. So I'm just printing ID of X here, and I'm printing ID of self here. Let us see, that is more readable than that. 1464982339152. So which means they both are one and the same. They both are one and the same, right? So new is the one which is creating the object. Now constructor is the one which gets called when we create an object, right? Now who creates an object in Python? Which method creates and takes care of creating an object? Which method takes care of creating an object in Python?
Constructor, sir.
Constructor is the one which gets called after creating an object, but
Okay,
which
okay, sir.
takes care of creating an object. What is this? What is that we discussed so far? New is the one which takes care of creating an object. New method underscore underscore new. Init method gets called whenever an object is created and helps us to construct the object by assigning certain values to it. Self dot first name, self dot last name, which we have seen in the other examples earlier, right? It helps us to build the object, construct the object. But who creates the object? Who creates the object? New. New method is the one which creates the object. Am I clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. If you see, first is when I created, all we have is this object creation syntax here. That's it. And which means this is trying to create an object. And once the object is created, which function called first? Which function did it execute first?
New, sir.
New
Underscore
function.
underscore new is called first. From there, it created an object. What is the syntax of create object creation? Here, line number 8. Super, and I have to give the class name and the class reference underscore underscore new, and I'm passing the class reference again. So this is the syntax which creates an object, and the same X is returned back. And now Python, whenever after creating this object, this is the object that is created in the new function, new method, and the same object is passed, and Python calls the init method by passing that object. So by the time your init is being executed, you have the object created. You have the object created. Am I clear?
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Now, wait, I mean, as I told, 99% of the time you will not be using new. What is that 1% of the time where we use the new, right? Now this is important. Okay. Now there is a concept called singleton pattern. Singleton, do not forget this. Okay. Singleton design pattern. Now here we should create a singleton class. We should create a singleton class. What is a singleton class? We should be able to create only one object for the class. We should be able to create only one object for the class. Every time create an object, it should return same object that is already created. That is already created. Are these statements clear? Singleton means you should be able to create only one object for a given class, only one object, not more than that. And every time I use a object creation syntax, it should return the same object, which is already created. If not created, create and give. If it is already created, reuse the same object. It has to use the same object. So it should not let people to create more than one object. Maximum limit is one object we should be able to create. Now, are these statements clear?
Clear, sir.
Okay.
Yes, sir.
Now, let us say this is my class. Okay, let us say I have not, okay, let me just, okay, right. Let us say I don't have a new method here. I have commented it out. We don't have a new method. All we have is what? Right. So we just have a constructor. Now what I do, I try to create multiple objects. Okay, so I'm creating three objects, bird1, bird2, bird3. Okay, I'm just going to execute. Now bird1, bird2, bird3. Are they same objects or different objects?
Different.
Right, different objects. If you see, their memory addresses are totally different. Every time you create an object, it will create a new object. It will not reuse anything. So it will try to create a new object. They are objects of a same class, but they are different to each other. Is it clear?
Yes, sir. Yes, sir.
They're
Clear, sir.
objects of a same class, but they are different to each other. Clear?
Yes, sir. Yes, sir.
Okay.
Yes,
Now,
sir.
what does, so this is a regular class, regular way of creating objects. Now, what does the singleton class statement say? Every time I try to create an object, it should return the same object. It should not return the new object. So at this point in time, it should create an object. And here, whenever I try to create one more object, it should return the same object for me. It should return the same object for me every time I try to create a new object. It should not create new object. It should create one object and reuse the same object. It should not let people create more than one object. Understood?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Now, for that, what should we do? Class singleton, that is my class name. So def underscore underscore new underscore underscore. Right? New is the method that I have just overriding. So by default, it has its own implementation. Now I am overriding that behavior. Okay. So what is that we should return? We should return the object. We should return the object. Okay. Whatever is this parameters that we have taken here, right? Same thing should be passed here. Right? That's it. Now this is the one which creates an object, right? Now if I say s is equal to singleton print s, I'm creating an object here. S1 is equal to singleton print s1. Now if you let me just run this. Now what is happening here? They are still not the same objects, right? So one, if you see here, D4A5, D4A6, they are not same. D4A, D4A6, D4A5, right? These are not the same objects, yes or no?
Yes, sir. Yes, sir. Yes, sir.
Right? The idea is that we should, singleton pattern means what? We should allow only one object to be created. We should allow only one object to be created. Now this is the one which creates an object. Now what I'll do, create a simple variable here. Instance is equal to none initially. Instance is equal to none, right? Now what I'll do here, a simple thing, if not instance, if not instance, cls dot instance, only then create instance. Only then create the instance object. Now what I'll do, right? So which means for the first time this value is none. For the first time when we create a class, for the first time this value is none. And now because if not cls dot instance means if it is none, right, then only create an object and assign it to it. And whatever is the object that is created, return that object, return that object. Now if I run this, are these both same? They all are going to be same. How many ever objects I create, they all are going to be same. They are They're just same. How did I achieve? How did we achieve that we were able to control how many objects are going to be created in this class, right? We overrid, we have overridden the underscore underscore new method. That is the one which creates an object. And there I have put a control that this should create only one object. We know that whenever an object is created, new method is called, right? Now I did a class variable. I did a class variable, right? We had a class variable, which is instance equal to none. We have not assigned anything to it, which means none. Basically, it doesn't have anything. None means none, right? And if not class instance, meaning if at all, if class in cls dot instance doesn't have any value, if cls dot instance doesn't have any value, then create an object and assign it to cls dot instance, that class variable, right? Assign it to instance variable, which is the class variable, and return that class variable. Done. Now, once this object is created, class variable has the instance now. Okay. And every time the object is being created, it will check, okay, does it have a instance? So it already has an instance. After the first time, it did not have. And second time, for the first time, yes, when it was checking, it did not had an object. And after that, we are creating an object and assigning object to this, right? Which means it has an object. Once it gets an object, it is returning that object. We just made use of one class variable to control how the objects are going to be created. Okay. And we ensured using the class variable, we ensured that this class will always return the same object. This class will always return the same object, right? This is nothing but a singleton class. Now, in the interview, when someone asks you, write a singleton class, you have to explain what is a singleton first. Singleton class is a class which ensures there is only one object created for that class, not more than one. Okay, and every time we try to create an object, it returns the same object that is already been created, right? Is it, do I make sense?
Yes, sir.
Yes, sir.
Right? And now if
Yes,
they
sir.
ask you to write a program, this is the small tiny program that you have to write. And there you go. This is one of the most important interview question. Okay. So you have to prepare, you have to try multiple times that you will never forget this. Are we clear?
Yes,
Clear,
sir.
sir.
Okay, you have to practice in such a way that even if somebody wakes you up in the sleep and asks this question, you should be able to write this much.
Okay, sir.
Okay. Now that is where this is the case where
Yes,
we
sir.
use new to control how the objects are being created. Okay. Now another question is, I want to know how many objects are being created. How many objects are being created for a given class? How many objects are being created? How can I know? See here, I have just created, copy pasted so many things, right? Now I want to know how many objects are being trying to, I mean, how many times an object is trying to be, how many times we are trying to create an object. How many times we are trying to create an object, right? I want to know the count. So how can we do that? We know every time we create an object, which method gets called?
New is called,
New
sir.
method.
New. Now in that,
Hmm.
just like now this class variable, can I add one more variable? In this, can I just say every time you try to create an object, the count keeps increasing, and eventually what I will say, I'm just going to say print. This will basically tell how many times we try to create an object. So in this 12 times we try to create an object. Shall we just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Did it give the correct count?
Yes, sir.
Yes, sir.
Right? Did you understand what we just did here?
Yes, sir.
Yes, sir.
Okay. Now practice this very important. This interview question will be asked not just as a fresher, even after 1 year experience, 2 years experience, 10 years experience. I ask this question in interview for anybody like, below 5 years experience. I will just randomly ask, can you write a singleton class? Explain what a singleton design pattern. Can you write an example for it? Right? And this is something that is very much expected if you're a Python developer. I'm telling, not just as a fresher, even if you're a 5 years experienced developer, I would ask this question. Do you understand the importance of this question? It is not just for today, not just after like, once you get a job. This is for you. Even if you are at 5 years experience, this question will be asked. So practice well and do not forget. Clear?
Okay, sir.
Okay, sir.
Clear, sir. Yes, sir.
All right. Okay, so we'll proceed further. Another thing, important thing is called MRO. MRO. What is MRO? Okay. Let us say I
Okay,
have
sir.
a class. Um, okay, so let's go with the same thing, right? Class person. Okay. Def underscore underscore init underscore underscore. Let me not even go with the constructor. Let me not even go with the constructor. Def set first name. First name, right? Self dot first name is equal to first name, whatever is being the variable that is passed. Now class inherits from person, right? So def employee def okay. So we have a multi-level inheritance implemented here. So the base class is person, base class is person, which is getting inherited into a class called employee. a class called employee, and employee is being inherited into another class called manager. Are we clear? This is what we have implemented.
Yes, sir.
A class
Yes,
called
sir.
person. Person is
Yes,
being
sir.
inherited into employee, and employee is being inherited into class called manager. This is a multi-level inheritance. Right. Now, what is that we are trying to understand is a method resolution order. Now, what I'll try to do is x is equal to, we are trying to create object for manager class. We are trying to create object for manager class. Now, x dot, right? Let me just say x dot set first name. Right, it takes one parameter. Now, how does it know? How does your language know? The Python knows, right? That now, so manager class, do we have a set first name method here? It doesn't,
No, sir.
right? Does employee, which is inherited into manager, does it have a set function name, say set first name,
No, sir.
right? Which function, which class has the set first name? It is the
Person
person
class.
class. Now,
Person
Person.
eventually,
class.
person is inherited into employee, employee is inherited into manager. But so manager also has access to all the methods of the employee and also all the methods of person. Yes.
Person. Yes. Yes, sir.
Now, how does Python resolve this method that it should go to person? It should go till person to find this method. To find this method. That is what is a method resolution order. What is the order that it tries to resolve method? Now, first it checks in manager class. First is always the class that we are trying to create object on. First it checks here. Okay, do I have a method here, which is the set first name? Does it have in a method? It doesn't find
No,
this.
sir.
Okay, then it will go to the immediate parent. It will go to the immediate parent. Okay, do I have a set first name in the employee class? Okay, no. Then it will check, okay, where am I? Where is this in getting inherited from? Okay, person. Okay, then it will go and check in the person. Okay, do you have a set first name method? Yes. And then it executes there. Then it executes there. Right? The order is always on the class which we are creating an object. So that is where it checks first. Okay, do I have it here? Okay, no. Then do I have it at employee? No. Okay, do I have it at person? Right. Right. For example, at your home, there is a child. Okay, there is a child who is born and he will be using, let us say, left hand. Example. And now you will try to, how do you check how did this fellow got the left hand? First you will check, okay, first you will check with their parents, right? Do you have a left hand? Do you have a left hand habit? They will say no. Okay, then what do you do? Okay, does your parents have, you will ask the parents, does your parents have a left hand habit? They might say no. Then what will you do? You will go to one level above. Okay, do your grandparents have the left hand habit? So that is how we try to resolve, right? Okay, how did this gene come to this new kid? Yeah. So in the same way, whenever we are trying to create an object, sorry, call a method, and particularly when you have multiple or multi-level inheritance, it is that first it checks in the base the class way on which the object is created, and if that doesn't have it, then it will check, okay, is it being inherited from someone? Yes, it is inheriting from employee. Then it will check in the employee class. Okay, boss, do I have the set first name method in the employee class? No. Right, but where is the employee class being inherited from? Okay, it is being inheriting from person. Then it will go check in the person class. Okay, do I have the first name set first name method here? Yes. Okay, then fine, it is going to execute here. Then it is going to execute here. Did we understand how this method as a resolution order works?
Yes, sir.
Yes, sir.
Right. That
Yes,
is the
sir.
order. Now, there are two kinds of inheritance that I told that are there in Python. What are they? Multi-level. First, we have single, right? One class, one base class, one child class. Base class, child class, not more than that. Yes. Then we have multi-level. One base class, one child class, another child class, and so on. Right? Then we have multiple. Then we have multiple. Right? Two parent classes and one child class, both are inheriting. So you have one parent class A, parent class B, and child class C inheriting from both A and B. Both A and B. Right. Multi-level, we are clear. Yeah. First it checks in single, no problem. First it checks in child class. If it doesn't find, it will check in the parent class. Same logic here. First it checks in child class. If it doesn't find, okay, it will go to the immediate parent. If it doesn't find here, then it will go to the immediate parent and check until it finds. It keeps going. And once it doesn't find in any of the parent hierarchy, then that is where it rises attribute error. Attribute error. If it doesn't find that function anywhere in the inheritance cycle or inheritance hierarchy, then it will raise attribute error. Clear? Okay, so
Yes,
in the
sir.
multi-level, it is clear. Okay, it goes to parent, from there it goes to parent and so on. What happens when it is a multiple, right? So it goes from left to right. So first inheritance is on which class? A is inherited first, B is inherited next. A is first, B is next. Okay.
Okay, sir.
Now first it checks in A, then it checks in B. It goes from left to right. Okay, clear? Now what
Yes,
happens? I
sir.
use a combination of multi-level and multiple. Multi-level and multiple. So I have my parent class A, I have my child class which is B, and I have another child class which is C, and I have another child class which is D, and C is inherited into D, and D is also inheriting from another class called E, and E is inheriting from another class called F. Okay, now this is a combination of multiple and multi-level. This here is a multi-level, this here is a multi-level, but C and E are being inherited into D, and this becomes here it is multiple. Here it is multiple. Clear?
Clear,
Yes,
sir.
sir.
It is a combination of multi-level and multiple. Now, if you see, if I have a class A, right, nothing in this, and I have class B inheriting from A, right, and then I have class C inheriting from B, and at the same time we have few more set of classes, which is class F, again class E inheriting from F. Now class D inheriting from C as well as E, right? So this was a multiple, sorry, this is a multi-level. This is also multi-level, but when it comes to D, it is inheriting in a multiple, right? Because it is inheriting from C and it is inheriting from E, right? Now, in this condition, right? How will the method resolution order works? Right, left to right. So C is inherited first and E is inherited next. Left to right and depth first. Left to right and depth first. Okay, left to right, depth first in this case. So method resolution order works always
Left to right, sir.
left to right and depth first and depth first. Okay, so now let me just write a simple function here. Class A has function test. Okay, class A has function test. Class B has function help. This is A, this is B. Okay, and class C has a function named magic. Okay, now let me just draw this first. Now you have to properly tell me how things work here. Okay, this is D, F, this is E, and this has also test. This has happy. Okay, now concentrate towards the left here. What I'm going to write, x is equal to D. I'm trying to creating object for D, and I'm going to call x dot test. Now, how does the method resolution order works here? What is the simple rule? Left to right,
Depth first.
depth
First.
first. Okay, what do we mean by that? This is the depth. We always go from left to right and depth first. Okay, x dot test. Tell me the flow.
It will first
I
go to
am
magic class.
first. It will check where first. Which object is this? D object. Yeah.
Yes.
First, it
Yes,
will
sir.
check in the D
D.
class. First, it will check in the D
D
class.
class.
Next, it will go to
C class.
right, left to right. The
Yes,
inheritance
sir.
of D is C, comma
C.
E.
E.
Right. So left to right as in first is a C. So first it will check in the C
C.
class. Okay. Next, what do you say? Left to right, yes, and depth first. Okay. Now is C is being inherited by some other class? Yes, it is
Yes,
being
sir.
inherited by B. So it will go
B.
check in the B class. Right. Then it will check in the, okay, is B being inherited from okay, test is not found in the C class, B class, C class, and B class. Okay, then is B being inherited from some other class? Yes, it is being inherited from A.
A.
Then do I have test method in A?
Yes, sir.
That's it. We found it, we executed it. Done. Okay, now I want to say X dot happy. Now, how does the flow work again? First, in which class does it check?
D.
B class.
First, it will check in the D class because this
D
object
class.
is of D. Then
Yes, sir. It will go to C.
it will go to C. Then
C.
Then B class.
B class. Then
Then A.
A class. Now, is there any parent class above A?
No.
Now,
No,
depth
sir.
is completed.
Yes, sir.
Yes.
Then
Yes, sir.
it will go to left to right. Now, depth is completed. Then next class, which is
E.
then it will go
E,
to
sir.
E. Done. After that,
F.
do we have
F,
happy
sir.
function in E?
No.
No. Then it will go check in F.
F.
Do we have a happy there? Yes.
Yes.
It
Yes, sir.
executes.
Yes, sir.
Right? Now, this
Yes.
is what the method resolution order works. Left to right, depth first. Right? In interview, can they, if they will ask you a question, what is method resolution order or what is MRO? Can you explain it? Right now, you should be able to explain this much. Method resolution order is a way how a method gets resolved in the multiple or multi-level inheritance, right? And it is always left to right and depth first. And then you can give this example. Can we do this?
Yes, sir.
Yes, sir.
Right? Very, very important interview question. Again, yet another very, very important interview question. Clear?
Clear, sir.
Clear, sir.
Okay,
Yes,
we'll
sir.
try this concept.
Clear, sir.
Yeah. In the inheritance, I'm just going to write or create a new class. All right. So class A, which has a function called def test. Function from A class. Class B inheriting A. What is the function? Help. Inheriting from B. Class F. Inheriting from F. And what does class E have? Test. Class D inheriting from E, sorry, C, I think C is the one. Yeah, C comma E, multiple, right? Does that have help? Class D. Now, all right. So I want to check the MRO first, right? We decided it was always this is good. This is what the MRO looks like. D, C, B, A, E, F. Right. Now let us ask Python, is that true? If I want to know what is the method resolution order, I have a function. I have a function. Print D dot underscore underscore MRO. So this will basically print the method resolution order hierarchy, or D dot MRO. So this should be created an object, and let me just check this class. Let me just execute MRO class. Right. If you see here, first it will check in D, then it will check in C, then it will check in B, then it will check in A, and it reach the depth, and then it will check in E, then F, and you can remove. So by default, all the classes in Python are inherited from object class. By default, all the classes in Python are the children of the object class. So it eventually checks in object. So this is the method resolution order for this class that we have created. So how do I know what is the method resolution order? You have two functions, which are underscore underscore MRO underscore underscore, and you have MRO as a function itself. You have MRO as a function itself, which can tell you what is the method resolution order sequence. Are we clear?
Clear, sir.
What does it say?
Yes, sir.
D,
Clear, sir.
C, B, A, E, F, and lastly object. D, C, B, E. Okay, D, C, B, A, E, and F. Did we get it right?
Yes, sir.
Right.
Yes, sir.
So this MRO function, MRO is also important. Okay, where what is the method resolution order sequence on a inheritance hierarchy, and you should be able to explain that much. And how do you validate? You have a method called MRO, or underscore dunder function, which is underscore underscore MRO underscore underscore, which will basically give the inheritance MRO sequence, you can using which you can validate. Right. So are we clear with this?
Yes, sir.
Yes, sir.
Yes,
Clear, sir.
sir.
Okay. All right. So we will end the class today here, and tomorrow. Okay, I'll update on the class tomorrow. Okay. So it is a holiday. I'm not sure about the availability. I'll confirm on the tomorrow's class. But today, I want you guys to practice both the singleton design pattern as well as this MRO and the inheritance concepts that we have discussed, because these are very, very important. Very, very important. Okay, not see, don't learn something for to crack an interview. Learn something to gain knowledge, and the knowledge will eventually give you the result. Okay,
Okay, sir.
Okay, sir.
okay.
Okay,
Yes,
sir.
sir.
Right. So let me stop recording.